initially, the first thing it does is just some data wrangling. It just makes sure that all the characters match up to the scenes, and we've got actual objects, we don't have references, a few other things like that, right? There's a bunch of things it does about filtering as well. So it filters out scenes that only have one character, and then it filters out characters that don't appear in any scenes, and then it has to go back and do that filtering out the scenes again. There's a bit of a loop there. You can see my little to-do. Ash Kid had a very good recommendation on this that I never implemented, and now his gist has gone away, so I have no idea what it was. And then we get into some more interesting stuff. So the first approach I took to try and decomplexify this thing is, basically it's a problem of ordering, right? So we want to get the character lines in an order and the scenes in a vertical position that result in the least overlap and the least kind of confusing, crazy spaghetti. And so the first approach I took is to try and cluster the characters into groups that are most likely to be together in scenes. And for this I just used a stock standard community algorithm, a community detection kind of thing, called Luvian. This is just a JavaScript module. I've modified it a bit so it works with CommonJS, but you can download it. It's now MIT licensed, which is kind of cool. And basically it takes a graph diagram like this. It takes a bunch of nodes and the connections between the nodes and a weight of those connections. So in our case, that's how many scenes the characters appear in together. And then it just groups them into a bunch of different groups. So from that's where I took my initial order. So I figured if we just put all the characters together and started in that order, it would reduce the complexity of the crazy spaghetti. And it did a little bit, but it was still pretty complicated and it certainly wasn't near enough. So I got a bit more involved. And as well as doing that, I started grouping the scenes. So I took each scene and found on this, for the rest of this source code in fact, wherever you see the word median, think mode. I just got that entirely wrong. Anyway, so it basically just takes all the scenes, looks at the characters, and finds for each scene the modal group, so let's make that a bit more simple. The group in which the most characters in that scene are assigned to. Does that make sense? I know, this is the very start, it gets even more complex. I'm sorry, I'm so sorry. So we put the scenes in groups as well, and so we've got a better idea of which order down the screen we're going to put the scenes in. And then we also have to group appearances within scenes, right? Because within each scene, if you go back and look at these guys, within each scene, the characters have vertical order within the scene as well. So optimizing those is important to reduce the spaghetti as well. And then once we've got each scene and each appearance kind of assigned to a group, then we need to sort the groups. And initially I got this wrong, and maybe I still got it wrong, but initially I had the most populous group, the second most populous group, and so on down the page, right? But it turns out that doesn't help reduce the clutter and the complexity. And what I did instead is I kind of alternated them. So I had the most populous group at the top of the screen, and then the second most at the bottom, and then worked further into the middle. So the least populous group, where there are a few scenes and few characters, was in the middle. So it kind of opened out the diagram, and there was more white space, and it became much easier to read. And then I did some stuff about group position. So basically, if you can imagine a horizontal band, a bunch of horizontal bands across the diagram, each group got assigned to a band, and kind of just as a way of organizing it in my mind more than anything. I'm sure there's a better way to do this in code, but I needed that just kind of to visualize how this algorithm was working. And then I looked at the character group positions, as I said before. That's important as well, and that's essentially about taking the average scene position of each of the characters and then ordering the characters within the scene so that they're less likely to have to loop back above a different scene or below a different character within their own group. All right. Everyone on board? Like you could rewrite this now, yeah? Yeah. Actually, since I mentioned it, do keep in mind how you might rewrite it, because I'm really interested in your feedback, because I'm sure there's a better way, right? I know there's a better way. But I got way, way deep into this before I had a chance to kind of review it, and it had already taken a long time. Working in news, we've got deadlines, just had to get it done. I'm sure there's a better way. Feel free to tell me what it is. All right, so then we had to sort the group appearances. This is essentially just adding another little tweak. Like every one of these little, every one of these new steps is as a result of me running the thing and then going, actually, like that's too complex. And if I just change the order in some predefined way, I could de-kink a little bit more. Then I did some really boring stuff. Ideally, would support different scales on the x-axis, but for right now, it's just chronological. Ideally, would support dates, so each scene could have a date or a time within a chronology, and they do spaced out accordingly. That doesn't happen yet, but it might sometime in the future, especially if someone submits a pull request. All right, character positions. This is just a sorting algorithm. It's just goes through each scene. You can see it's just an array sort, and it just tries to sort out which order the characters are. It tries a few different things. Basically, tries simple group order. If you can get a result out of that, if that's perfect. But if they're in the same group, let's try something else. If they're not in if they're in the same group, then we'll try the average position within their group and compare that. If they're the same average position as another character, then we'll try something else. I couldn't think of another thing to try, so all else fails. I just wanted to keep it consistent and keep it in the order that they are in the original characters array. Scene positions is just about positioning the scenes on the y-axis, and that again is just about finding the average group of all the characters that are in that scene and trying to reduce the overlap again. All right, this is something I left to last, which in hindsight was a massive mistake because it's more complex than you imagine. So the introduction nodes, if we go back to it, you can see that each character essentially has a scene of their own right at the beginning, which is just an introduction to the character. This person starts here, enters the story here. I thought, that won't be a problem, I'll just tack on an additional node at the beginning of the array, render it. It turns out that the rendering of those labels is quite complex because you have to try and avoid collisions with other scene, other character introductions, right? So you can see like, R2D2 starts here, but then if we just put C3PO right there, he'd overlap R2D2 a little bit. And Stormtrooper is the same thing, and it gets worse and worse, and they all just end up on top of each other. So, so this is, I'm not going to go through this in any detail because, to be honest, it's a terrible implementation. It could be done a lot better, but calculating those introduction positions is more complicated than I expected, and as well as just introducing them in the right spot, if they were close to the beginning, I wanted to pull them all the way out to the left-hand side just to make it a bit cleaner and clearer again. So that was an additional complexity. Yeah, so you can see this code goes on for a while and it really shouldn't have to. All right, and the final kind of output that the algorithm needed to provide was just a method for calculating the Bezier curves, the links between each of the character nodes, and that's pretty easy because D3 is awesome and it gives us that for free, essentially. There's a couple of little utility functions at the bottom. All right, so that's basically it. Now, just to wrap up, all I'm going to do is talk quickly about what I think I might do differently if I was going to do it again, and maybe get some input from you guys if you've got any ideas what you might do differently. The major thing I do differently is I turn it into a pure optimization problem. I think there's probably some explicit instruction you need to give the layout. I don't think it could be a pure optimization problem in the end, but I would start there at the least. And I would give it just a bunch of input parameters, and I would use some, I I don't know, Monte Carlo simulations, and I would give it a bunch of calculations to do and just find the best one, right? Because computers are pretty good at that. So that's where I would start next time. And I think it could be doable. And a really good example of that, actually, in D3, if you're looking for that kind of thing, is, where is it? Is a D3 labeler, does exactly that, which I don't have the internet for. Anyway, you can look that up. D3 labeler is just a layout for D3. You throw out a bunch of labels where they should be and their sizes, and it'll do exactly that. A bunch of Monte Carlo simulations. It has a cost function in it, and the cost function is all about overlaps and whether they're off the screen or not, and it finds the best scenario over n iterations. I think the default is 1,000. So yeah, it's pretty quick. That's it. That's all I got for you. So that's me. If you want to get in touch, or if you just want to come and have a chat afterwards, that'd be fine as well. I'm all ears about your... Yes, Nigel.
Where do you get the data from?
Good question.
Who are the people that sit there and...
In both cases, we basically compiled it by hand. So the ICAC one, one of the journos in my team I work with, he read through all of the transcripts of the court proceedings, essentially, and picked out where people were meeting or when they were kind of interacting in some way, and put that into the data set. And with the Star Wars one, a very dedicated journalist in the ABC News team watched all 6 Star Wars movies, including the prequels. And it was actually a mammoth effort. She said it took her, most of it done on her spare time as well, so really dedicated. She said it took her 12 hours per movie to put the data together. So it's an effort.
Do you have an example of what the data looks like that you came through?
Yeah, I can show you that. Let me find it. Alright. Oh, that's not going to be very well, is it? Alright, so in this case, this is actually a bad example, sorry, but I'll tell you what's going on here. So because it was a shared responsibility to put this data together, the best tool we've found for that job is actually Google Spreadsheets, really good concurrent editing. We put all that together in spreadsheets and use a Node module that pulls the data from Node, and from Google, and this is what we get straight out of Google. It's essentially just a spreadsheet. And then I've got a script that runs through that and turns it into, it's just an array of scenes with one of the properties is characters inside the scene, and they're just reference links to character objects. So it's really pretty simple data structure. Yeah.
So in movies, what timeline do you use? Because like in real life, you can use like time.
Sure. Yeah.
What about movies?
Yeah, there's a bit of debate about this with Star Wars, especially because you can get like flashbacks and sometimes there's like vast spans of time, and then like all this action happens, and then there's another vast span. So as I said, I hadn't coded date into the viz at all, so it's simply a chronological order of events, which can also be tricky because sometimes you'll see 2 scenes next to each other and you don't actually know which order they happened in, but you can only assume that, like, the movie kind of suggests they're happening at the same time, like they'll splice together and they'll cut in and out, and you just sort of have to choose one to start with.
This is, one of the examples is, I think it's episode 5, that there's, Luke goes off to train with Yoda,
right? And
at the same time, like the rest of the good guys go on a big journey. And if you look at them both, it switches between them, which would suggest that the journey across the galaxy took like 20 minutes.
Yeah.
Even though in the narrative, far too many things seem to happen for that to be possible.
And so like this is one of the reasons I find these charts really interesting, right? Is because it lets you spot stuff about a narrative that you wouldn't have spotted before. And one of the things is like Luke's training is like this long. Like it's like he becomes a Jedi like that, right? And also the relative complexity of the different movies is astonishing, right? So episode 4 and well, all the originals in fact are really fairly simple narratives, right? We've got good guys and bad guys. They're on opposite sides of the galaxy. They meet a couple of times, tango a little bit, and then like the good guys come out on top, right? Pretty much like that's a really clear explanation of the movie. And then you get down to the prequels, and man, I mean, the number 1's not so bad, but it's pretty messy there, and. Like it just gets insane. There's so many more characters and so many more subplots. Like it's really interesting, just on a kind of a storytelling level, how movie making has changed between the originals and when the prequels were made 10 years ago.
I bet you 7 would look almost the same as 4.
Yeah, it would look pretty close to that actually. Yeah.
Does it refuse to render any character with Jar Jar in there?
No, it doesn't. Well, we didn't want to take too many liberties with the data, but I appreciate the sentiment. Yeah.
Who shot first?
Well, we went back to the pre-director's cut versions when we were compiling the data. So you know, it's not in there. I'm not going to buy it. Yes?
It'd be really cool if you could get those generated for like a lot of movies. And
totally,
correlate them with IMDb ratings and see if there's some kind of...
Yeah.
I mean, it's just 12 hours of movies, so who cares?
Yeah, exactly. It's just 12 hours of movie. Like, we need some sort of API that has characters and scenes in it.
Is the data open source?
The data isn't yet, but we are hoping to put it up open source. We can't put all of it up because the character descriptions we've taken from somewhere that's licensed, but the scene stuff we could definitely put up, and we're hoping to do that.
It's rendered client side, right?
It's rendered client
So you
side.
can get the data.
You can get the data. Yeah, you can totally get it.
Prior
The layout algorithm I just put up on GitHub on the weekend. It's MIT, so feel free to play with it. The actual bit that does the rendering, the SVG and the D3 stuff isn't up there yet. And I don't know if it will be. Like, it's going to be a bit of work to kind of get that in a public state. But this gives you, as I said, all X's and Y's. So if you want to go and play with it yourself, you can render it using Canvas or whatever else you want to use to render it. Yeah.
Have you seen the version where they did this with books? Where
I think
they
so.
analysed books for scenes and characters and tried to find narratives and
Okay.
similar between books?
Okay, that's interesting. So the original comic, this was done on comic books. So the first D3 implementation I saw was done on comic books, and that was a purely automated process. They actually had a Python script that analyzed the comic, looked for scenes in that. So that's like an effort in itself. I'm amazed that they managed to do so well.
Obviously with ebooks it's a lot easier because it's just text.
In some ways it's a lot easier, but it'd be that's a lot of natural language analysis to try and pull out the scenes that people are involved in. I think it would actually be not too hard to do with movie scripts if you could get your hands on the original script, because they're quite well formatted. There's, character says this, and stage instructions are often formatted differently, so you could probably parse those pretty well, but it'd still be a challenge. Yeah.
Speaking of data input, did you consider at any point creating just a standalone UI for inputting the data? More simply, like having a list of characters you can pull up when creating your scene?
It'd be a nice idea. I think it's just time. Yeah, we didn't have time for that. The Google Spreadsheets option actually worked out really well for us. Just like I said, the biggest reason is concurrent editing. It's really good at that, and when you've got 3 people at 4 AM finishing this thing off and trying to find all the things that Star Wars nerds the world over are going to pull us up on the next morning when it goes live. It's really helpful to not have version control issues. Yes, last question.
How long did it take you to code, and how long was the whole project for the team?
That's a tricky question. I think The layout algorithm probably took me a couple of weeks, I'd say. But it's difficult to answer simply because the newsroom environment I work in, like if there's a breaking story, like I have to down tools on this and start up somewhere else. So it's sort of not an easy thing to add up sometimes. But it wasn't a short process. Like it took a bit of time. Thank you
very much, Simon.